All right, so here we have example question number 3. 5 grams of aluminum sulfide and 10 grams of water react until the limiting reagent is used up. Here's the balanced chemical equation, which is always step 1 in a stoichiometry problem. Letter A says which is the limiting reagent, so we're going to have to go through step 2.5 to figure that out. And so we're given 5 grams of the aluminum sulfide. Multiply sign, put a line, because we're going to convert to moles right here. So I'll put grams in a position where it's going to cancel. Moles of Al2S3 is my new set of units. Skip a line, and then I'm going to take my water, 10 grams of water, and I'm going to convert that to moles. There are 18 grams in 1 mole of water, which get that because there's 16 oxygens for each oxygen and 1 for each hydrogen. And then Al2S3 adds up to 150 grams in 1 mole. So where did I get that? Aluminum, remember, is 27 times 2, because there's 2 of them. And then sulfur's 32 times 3, because there's 3 of those. Okay, let's do this math on the calculator. 5 divided by 150. I get 0.3333 moles repeating of the Al2S3. And then for the water, 10 divided by 18 is 0.5555 moles repeating. Okay, so now that I've converted to moles, I need to divide by the coefficient. And the coefficient in front of Al2S3 is 1, so I'll divide it by 1. And the coefficient in front of water is 6. So I'll need to take this 0.5555 repeating it divided by 6, and that ends up being 0.0925. This number, of course, is still larger than this number, because you compare these two, and you ask who is the smallest. And the smallest is your limiting reagent. And so this guy is the smaller one, which means it'll be used up first. So my Al2S3 limits this reaction. So when it asks which is the limiting reagent and show work to justify your answer, here's the way that you can do that. After you divide by the coefficient, which one ends up being the smallest, and 0.03 is smaller than 0.09. So that's letter A. Now in letter B it says, what is the maximum mass of H2S which can be formed from these reagents? So now I take my limiter, which is my 0.0333 repeating moles of Al2S3, and it says what is the maximum mass of H2S that can be formed, and I do my mole to mole ratio right here, putting H2S as my new set of units, Al2S3 on the bottom, and for Al2S3 there's a 1, and for H2S there's a 3. Notice I got those from the balanced chemical equation right here. And it asks for what's the maximum mass that can be produced. So I have to go to the last step and convert to the asked for units, because right now I have moles of each of these. And so I will go from moles to grams of H2S, in this case, to grams of H2S. And 1 mole of H2S added up on the periodic table, sulfur, remember, is 32. Hydrogen is 1 plus 1, so 34 grams. So let's run that through the calculator right here. 0.03333 repeating times 3, enter, times 34, enter. The maximum yield is 3 going to, let's see, 3 sig figs here, because that's my limiting number of sig figs. I would have 3.39999, so look from this 9 to the next one, round that up, that's going to have to be a 4. So 3.40 grams is my maximum yield that could be produced. Okay? It's the maximum mass right there. And then letter C, how much excess reagent remains after the reaction is complete. So I know that water is my excess reagent, but I always want to start with my limiter. So start with my 0.03333 moles of Al2S3. And now to find out how much water is actually being produced, we need to do a comparison, a mole-to-mole ratio between Al2S3 and the water. Okay, so I want to compare these two because I want to know how much is actually going to be needed when this guy's completely used up. So I start with my limiter. Always start with your limiter. If you're in doubt, just put the limiting reagent down. And then you're going to have to compare it to the one, in this case, that's in excess. For every 6 of these, there's one of these. There's a 6 here and a 1 here. And this is going to tell me how many moles of H2O are actually going to be used up. So on my calculator, I'll do my 0.03333 repeating times 6, and I'm going to actually use up 0.19999 repeating amounts of moles that are used. Now here's how much water I started with. Here's how much I'm actually going to use. Now I need to find the difference between those two. And so I'll take my 0.55555 repeating minus, and I'll just do second answer right here, and I end up with 0.3555 moles of H2O that are left over. Now the question doesn't say whether it should be grams or moles, it just says how much. And so I'm going to leave my answer in moles right here, but I could convert to grams and I'd convert to the asked for units if need be in this problem.